Pretty much, yeah. They don't trust me. They think I'm just out drinking or something.
Yeah, you got French slides.
Yeah, I just delivered this in Quebec City last week. So. Oh, I was supposed to update that. Darn it. It says Atlanta. All right.
Quebec is French for Atlanta.
Exactly.
All right. Good evening, everyone. Thanks for coming out. We're going to be talking about Calico. Raise your hand if you're familiar with Project Calico. All right. At the end of tonight, everybody's going to raise their hand when I ask that question. So, all right. So we are here. Who am I? So I am a senior technical solutions engineer, which is some weird way to say a sales engineer. I am sales engineer for Tigera SE. I am based out of St. Louis, here in the middle of the country. I've been working with enterprise software since the late 90s. 7 years at Splunk, 2.5 years at Mesosphere, 6 months at Heptio, 6 weeks at VMware. And if you want to know more about that, come see me after. Besides that, ask me about history or my terrible Reddit addiction. So I had a guy from Reddit at one of my meetups, and I said, oh, and my drug dealer is here. He didn't appreciate that joke as much as I did. All right, so who is Tigera? It is not a super secret Pokemon. But we do have a conference room named after Meowth. And I had to ask my son how to pronounce that. So, all right, who is Tigera really? We are the commercial enterprise that is associated with Project Calico. Project Calico is the OG Kubernetes networking engine. So we were kind of the one of the original. We were networking containers before Kubernetes even came out. We were networking Docker Swarm. We were networking Mesos way before even Kubernetes was released. So Project Calico is open source. It is the #1 CNI plugin. Raise your hand if you know what a CNI plugin is. All right, again, at the end of the night, you're all going to raise your hands to that question. It is the #1 CNI plugin for Kubernetes. There are at least 100,000 Kubernetes clusters worldwide that haven't figured out how to turn off the phone home in Calico, and so that we know of. So there's definitely more than that, but there's at least 100,000 that haven't figured out how to turn off phone home. So besides being a CNI plugin, it's also a policy engine, and we're going to talk all about all of that here. Don't worry. Widely deployed, proven at scale. The biggest Kubernetes cluster somewhere deep inside Google runs Calico. Some of the biggest Kubernetes clusters anywhere at a certain fruit company in Cupertino as well run Calico. So it's probably the one of the most used at scale as well. So, in fact, it's used by AWS, it's used by Azure, and it's used by Google Cloud. So, if those three can agree on that, I mean, they don't agree on much else, as far as I can tell. All right. So, who's Tigera? Tigera is the commercial enterprise. We offer an enterprise solution that is based on Calico called Tigera Secure. This is a meetup, and I'm not allowed to talk about for sale software. I'm only allowed to talk about open source. So if you want to hear about Tigera Secure, come see me in the alley afterwards. I'll hook you up. All right. Yes, our strategic partnerships: IBM, Red Hat, Docker, Azure, all the big names. I'm going to make these slides available on GitHub as well as a PDF. So I'll send out the link to the meetup. So again, Project Calico, inventor and maintainer, Tigera Secure, extend firewalls to Kubernetes. All right, so what is Calico? Calico is networking for your containers. Open source project, most use CNI worldwide. Who knows? All right, so we all work in tech. Tech is death by 3-letter acronyms. Who knows what CNI stands for? Somebody shout it out. All right, good. Who knows what CSI stands for? No, crime scene investigation. Container storage interface, you're right. You're right. So if ever during this talk, I use a 3-letter acronym that you've never heard of, just ask me, I will tell you, because I've been in your shoes. I've been at a talk and they're like, well, if you just put your PDQ in the XYZ, it's just gonna run great. And you're like, I have no idea what he's talking about. So feel free, stop me and ask me. I'll make a joke about it either way. All right, so Calico is networking for containers. What does that exactly mean? So basically it can do a couple of things. Calico has 2 aspects. The first aspect is the CNI plugin. The CNI plugin hands out IP addresses for your pods in Kubernetes. It is an IPAM engine. I don't know what IPAM stands for, but I know what it does. IP address management. See, that's not even a 3-letter one, that's a 4-letter. So you can use Calico to hand out IP addresses to your pods. You can also use Calico to set up different subnets for different types of workloads. You could have one subnet for outward-facing workloads and another subnet for inward-facing workloads, just like you do in your normal non-Kubernetes stack. You can also assign static IP addresses to pods, and we actually have a lot of big banks that do this. They like to have specific pods that perform a specific function, and they want them to have the same IP address in every one of their clusters. So they have to use the Calico CNI to do that. Where else? So that's the CNI part. You can run the Calico CNI and not run Calico for policies. You can run Calico for policies and not run the Calico CNI. They're mix and match. You don't have to run them both, but they are better together. So the second aspect is Calico policies. And so these are network policies. And for some reason, we decided to stop calling them firewall rules, and we now call them policies. So whenever you hear me say policy, if you're old like me, just think firewall rule. All right. Secure your east-west traffic, prevent malicious behavior from spreading, typical firewall stuff. Okay, so where can you run the Calico CNI? You can run the Calico CNI in upstream Kubernetes. Does everybody know what I mean by upstream Kubernetes? All right, without a paddle. What? Nope. Upstream Kubernetes is just regular old plain Jane open source. No other company has touched it. It's the open source pure Kubernetes. Sure. No, yeah, upstream just means basic Kubernetes that hasn't been adjusted by Red Hat or adjusted by some other company to make it work in their particular situation. So you can use the Calico CNI for upstream Kubernetes, OpenShift, Docker, the artist formerly known as Mesosphere, D2IQ. I always want to say DQ, Dairy Queen IQ, but that's another story. Rancher, and if you've never heard of Anthos, Anthos is Google Cloud on-prem. Google Cloud on-prem uses the Calico CNI. Now, Calico for policies will run almost anywhere. This is a limited subset for the Calico CNI. All right. So, raise your hand if you've stood up a Kubernetes cluster with kubeadm. All right, right? So you stand it up and you're like, oh, I finally got it to work. And it's still like, then you do a kubeget nodes and it's like not ready. And you're like, what do you mean not ready? That's because you haven't installed the CNI plugin yet. So one of the CNI plugins that you can install obviously is Calico. There are two ways to run the Calico CNI. You can run it where it talks to etcd directly, or you can run it where it talks to the Kubernetes API data store. This one, the API data store, is slightly more secure, but you might find yourself using the etcd directly if you don't have control over your etcd, or if you're at a very large scale, you might want to have a completely separate etcd even for Calico. But those are the two options. You have to decide when you install. Questions so far? By the way, yeah, you can just interrupt at any moment with questions as well. I'm not a formal guy. All right, moving on. So now we're going to talk about how does Kubernetes networking work. And this is independent of Calico. So whether you're running Calico or not, this is how Kubernetes networking works. So, and it's also how most container networking works, whether it's Kubernetes or not. So when I first started working with containers, I used to explain containers like, okay, a standalone server is like a single family home. A VM is like an apartment. A container is like a hotel room. Not bad. But then when I started learning more about the networking aspect of containers, I learned containers are really, like if VMs are about sharing hardware, containers are about sharing the Linux kernel. Single kernel, multiple servers, basically. So because the kernel is at the heart of containers, it's also at the heart of container networking. The very first hop, if this workload wants to communicate with a workload over there, the very first hop in that network is the kernel. The kernel receives the packet and decides what to do with it. So here, comes here, kernel says, oh, you're going over here. Kernel sends it down to the NIC card. NIC card goes out to the network, comes back over here, goes up to the pod. Now, what if this pod over here is talking to that pod over there on the same node? Packet enters the kernel. The kernel goes, oh, this one's right here. Sends it right up there. That packet never leaves the kernel. Never even hits the NIC card. Absolutely never gets anywhere near your network. So if you're relying on traditional firewalls, traditional network infrastructure to manage your Kubernetes network, you're missing a lot of traffic that never leaves the cluster. So if your Kubernetes network security solution lives down here, it's blind to a lot of what's going on inside your Kubernetes network. Questions so far? All right. Yeah, when that one, it was a light bulb for me too. I'll be honest, I worked at Mesosphere for years and I never really thought this deeply about container networking. So, question? I could not hear you, I'm sorry.
If one of your Kubernetes cluster pods running a database, SQL database, would it make you more able to SQL injection type of type or?
It certainly, yeah, I mean, it could, conceivably, yeah. It's not, there aren't that many SQL databases running in Kubernetes. If you're going to do it, the Portworx guys are here. Talk to them because persistent data in Kubernetes is not for the faint of heart. Tell them to call Portworx. All right, so I'm not going to go over this slide because we're actually, but you'll be able to go over this slide when I'm done with this lecture. But this is kind of the high-level picture of how the CNI actually works. And when we learned about the CNI here, this would apply to other non-Calico CNIs as well. So if you're talking Flannel or Weave or some of the other CNIs that are out there. Now, if you're talking Flannel, you're coming to Tigera either way because we have Flannel as well. So Flannel became orphaned during all the CoreOS Red Hat acquisitions. Flannel became orphaned, so we took it in. So. And then, what's that? It's still alive, yeah. But we took some of the better parts of Flannel and shoved them into Calico. So, but yeah, it's still alive and still, I mean, it's still supported. There's still people working on it. Yeah, it's still used. And now, then this is the high-level policy architecture. I'll come back to that one as well. But first, let's talk about the Calico CNI IPAM. So, when you set up Calico, you give it a subnet to hand out IP addresses to your pods. Everybody with me so far? Yeah? Now, what Calico does with that subnet is it breaks it into /26 further subnets. So it gives you little 64 IP subnets. And it assigns one 26 subnet to every single one of your worker nodes. Every one of your worker nodes gets one of these 26 subnets, /26 subnets. No. Worker 1 gets this one, worker 2 gets that one, but the routes are in there for both. So what happens is all of those subnets that get assigned to all the different pods, all Calico will let all of the other nodes know where all those other subnets are. Now, the nice thing about this is you only have entries in your kernel for IP routes for the number of nodes that you have. You don't have it for the number of pods that you have. The other nice thing about Calico is if you run out, if you want to schedule 65 pods on this node, Calico will automatically allocate another 64 IP subnet to that node. Now, if Calico completely runs out of subnets to hand out, it'll borrow a cup of sugar from a neighbor. It'll find a node that has a spare IP, and it'll transfer that IP as a /32 over to the node that needs it. So you won't run out of IPs until you completely run out of IPs. A lot of the competing CNIs have much lower limits. They have things like 16 IPs per node and no more. So if you really want to bin pack, you should consider using the Calico CNI, because bin packing is all about shoving as many pods as you can in every single node to get all your money's worth. So I'm going to talk about that right now. So the other thing, as I mentioned earlier, Calico can have multiple IP pools for different workloads in your cluster. So if you have multiple IP pools defined, like up here on this slide, we have one IP pool, which is 10.0.0, and we have another IP pool, which is 192.168.1. It's going to allocate subnets for all the IP pools that you might have. Questions? Yes, both of those. It could be either one. You could have IPs from your VPC, or you could just make up IPs. Completely different. Yeah. In fact, I recommend completely different. Yeah. Yeah. Right. But then you can just use the made up IP ranges to go nuts. Kubernetes is very greedy on the IPs. I'm going to quote you on that. Question in the back there. Yes. Yeah. Yeah. When the node finally gets removed from the masters, that's when Calico's like, oh, the masters update etcd. Calico's like, oh, hey, they updated etcd. That node's gone. So we'll take, yeah, absolutely. But Calico waits for Kubernetes to update etcd and then reacts. More questions? I feel like I should be more of a stand-up with this mic like this, but all right, one more slide. Okay, let's go through the pod lifecycle. So we've got just typical cluster here, baseline Kubernetes, worker X, worker Y. It has the kubelet running on it. You got all the control plane up at the top there. Somebody logs into kubectl. Maybe it's a human, maybe it's a robot, maybe it's a robot butler named Jenkins, and issues a command to spin up a workload. So pods get scheduled on the worker nodes. So the kube scheduler works with the kubelets to find the right worker nodes and starts scheduling the pods on there. So it starts downloading the container images and starts building the pods. So one of the key functions it's going to have to do is it's going to have to set up IP networking for all these pods. And to do that, it calls the CNI. So it's going to call the CNI, and whichever CNI you've defined will be in etc CNI net.d. In our case, it's Calico. But in other case, it would be some other CNI. But basically, CNIs work the same way under the hood. So kubelet calls Calico. Calico looks to see, which subnets are on this node. But the first thing Calico does, and I always like to imagine Calico as like a little virtual IT guy going and running virtual network cables and setting up virtual NIC cards. So it sets up a virtual NIC on the node. All of those virtual NICs have the CALI and then a number. You'll see them if you do like an IP or an if config on the node, you could see them. Inside the pod, it's just the VETH, 01. So inside the pod, it just looks like a NIC card. As far as the services running inside that pod, they think it's NIC card. Containers have convinced workloads that they're on their own server. So they think they're on their own server. So gets an ETH0 inside each pod. IP addresses are allocated to each pod. And then Calico writes all of that information to etcd. Now, it writes it two different ways. It could write it directly to etcd, as in this slide here, or it could send the information to the Kubernetes API, and then Kubernetes writes to etcd. They essentially are the same thing. It's just two different ways of doing it. So once the Calico CNI writes to etcd, that's when the other Calico processes that are running. So Calico runs as a daemon set across your cluster. All your nodes, all your worker nodes, master nodes will have a Calico pod on them. Inside the Calico pod is the Calico container. The Calico container has multiple processes. They used to be split out into separate containers, but now they're all lumped together into one. But one of the processes there is Felix. Felix is also the Calico mascot. I have Felix stickers up here. You're welcome to them. If I go to a meetup without stickers, I get kicked out. So anyway, Felix sits and reads etcd all day. That's all he does. He waits for something new to get written there. In this case, the Calico CNI just wrote, hey, there's a bunch of pods there. Here are their IP addresses. Felix notices that. Then what Felix does is Felix updates IP tables in the kernel on its local node. So Felix is responsible for the node that he's running on. He updates IP tables in the kernel on the node that he's running on. All that information goes right in. Then the second process in the Calico pod called Bird uses a protocol called BGP. Raise your hand if you know what BGP stands for. What's that? I don't know, you tell me. Border Gateway Protocol. Yeah. Does anyone know of a network that runs on BGP? The internet, yes. When people ask me, is BGP scalable? I'm like, I don't know, is the internet scalable? All right, so the Bird daemon uses BGP to update all of the other Bird daemons in your cluster. So they create a full BGP mesh. They exchange routes amongst themselves. Now, if you are on-prem and you have networking equipment that speaks BGP, you can have that be part of Calico as well. You can have Calico program your top of rack router. You can have Calico work with different routers and switches that you might have, but you have to have full control over them. If you're in the cloud, you don't have that that luxury, but you absolutely could have Calico program your BGP and other things. I am about to run out of battery. Is there a plug nearby? Wait a minute. I can do this. Sorry, folks. Talk amongst yourselves. I thought I had enough battery to make it. I did, yes. Yeah, I see it. I was like 20%, that'll last. But it won't. Hey, all right. I can even get it over here. Oh, it's fine. If I fall, I fall. All right. So basically what happens is, again, the birds share the route across the cluster. If you're running a really big cluster, you can set up route reflectors. If your cluster is spanning a bunch of different subnets, you can set up all different kinds of things to go beyond sort of a 50-node cluster. If you install Calico with the defaults, that'll get you to up about 50 nodes. Maybe 100, depends on how busy your cluster is. But once you start growing above that, you're going to need to change some of the settings in Calico. And I have a talk on that, but it's not this one. I'm only half done with it, though, so forgive me. I'll come back and give it, though. All right, any questions on the CNI? Let me back up. So this is that slide. kubectl spins up a workload, talks to kubelet, talks to the CNI plugin, gets the IPs assigned, calls Felix, updates the kernel, calls Bird, updates all the other Calicos. So now everyone can raise their hand when they say they've heard of Calico, they've heard of the Calico CNI. All right. Now, another aspect of the Calico CNI is, how do you want to run your networks? Do you want to be a true overlay network, a true virtual network, or do you want to just use quote unquote real IPs from your networking infrastructure? You can go either way with Calico. Calico can hand out IPs that are fully routable across your network, or Calico can hand out IPs that are only available inside that VXLAN. That's your choice. You have two different ways of running it. Where you're running Calico might decide some of these choices, though. If you're running Calico in Azure, you have to use the virtual network. You have to use the VXLAN. If you're running it in some place like AWS, you might wind up having to use it depending on your topology. So, and we'll talk about that a little bit later. So well, hold on. I need to introduce, I forgot to mention something. So if you're just using quote unquote real IPs, then that's what you're using. They're routed just like they would be anywhere else. If you're using one of our virtual network or overlay networks, you have two options. You have the default, which is IP/IP or IP and IP. And then you also have VXLAN. We got VXLAN from Flannel. And really, if you're only time you're probably going to wind up with VXLAN is if you're in Azure. So, but we have multiple ways of running IP/IP. So you can do IP/IP always. When you have IP/IP always turned on, any communication that leaves the node will be encapsulated. So even if it stays in the same subnet, it's going to be encapsulated. If it crosses subnets, it's definitely going to be encapsulated. Or you could have IP/IP cross subnet. So any communication that stays in this particular subnet will not be IP/IP, and any communication that crosses does. If you're running an AWS and you've got your cluster spanning multiple availability zones, turn this on. This will make a lot more efficient use of your intra availability zone traffic. So this would be, you know, like US East A, and this would be US East B, for example, if you're in AWS. And Azure's getting availability zones. I'm sure Google's going to have them too. Questions on this? All right, so how does IP/IP work? Basically, it takes a packet, wraps another packet around it to send it across the foreign network. And then once it gets to where it needs to go, the receiving node unwraps the packet, takes the inner packet, and then sends that where it needs to go. Now, one thing to keep in mind, if you are using IP/IP, you will need to increase your MTU for this network here, or you may, depending on what it's set as, because these packets get bigger than typical packets. Who knows what MTU stands for? I don't, so tell me. Maximum transmission unit, thank you. You could use NAT translation as well if you wanted to. Absolutely, you could have it. You could have different NAT. You could turn on NAT translation as well if you wanted to. But if you don't have to, don't, because it becomes harder to trace things. It becomes more work. Your logs are less reliable, etc. when you do that kind of thing. But you could, yeah. And if in my example where we had multiple IP pools, you would have to have NAT turned on for some of those, depending on how you've networked your cluster. But you could, yeah, you could do NAT or not for when it leaves the cluster. That's kind of your choice. Good question. More questions? All right. So let's talk about IP pools. IP pools can be associated with namespaces, with workloads, or with topology. What does that mean? That means, for example, I could set up a namespace. Everybody knows what a namespace is in Kubernetes? All right. I can set up a namespace in my cluster that's called like DMZ. I could say, this is the namespace where I want to run my workloads that talk outside the cluster. My traditional, if you're in traditional tiered architecture, my DMZ. I could set up a namespace called DMZ. I could have an IP pool that is dedicated just to my DMZ. Then any workload that goes into the DMZ namespace would automatically pull from that special DMZ IP pool. What's the benefit? Segregation, tracking. In your logs, you see an IP and go, oh, this workload's running in the DMZ. You could actually, you can maybe see that right from the IP address. So you get this segregation, you get, a firmly defined network that's separate from the other networks. And as we're going to see when I talk about policies, that's really important in Kubernetes for lots of reasons. But You can absolutely set up an IP pool based on a namespace. You could also set up an IP pool based on topology. You could say, all right, I've designated these 3 nodes as my public nodes. These are my nodes that are going to talk outside the cluster. I want these 3 nodes to kind of be my DMZ, but I'm going to do it by node instead of by namespace. Works the same way. You say, all right, any workload that gets scheduled on these DMZ nodes is going to pull from that particular pool. You could have a pool per rack. You could have a pool per data center, if you know, whatever you want as far as topology goes. And then finally, you could just specify it at the workload level. You could say, all right, you know, Nginx has to pull from this IP pool, Kafka has to pull from that IP pool. Now you could do that too. You have all 3 of those options. And the way you do it, of course, is just with an annotation. You add an annotation either to your namespace or to your workload or to your IP pool. And yes, all of the escape slashes in this example are necessary. All right, here is an IP pool for topology. And yeah, I'm going to show you guys YAMLs. If you don't like YAMLs, leave Kubernetes now. It's death by YAMLs. All right, so this is our DMZ pool YAML. You can tell it comes from Project Calico because it says Project Calico. How about that? You can tell it's an IP pool because it says it's an IP pool. You give it a name. Everything has a name in Kubernetes. You specify a CIDR. And then here's where you say, what kind of overlay do I want? IP always, IP all cross subnet, or never. And this is where you can also turn off and on NAT, as I was telling you, you can set it up. And then here, since we're doing this for topology, we have a node selector type DMZ node. So what that means is any of my nodes that I've added the key value pair of type DMZ node will pull, any workload scheduled on those nodes will pull from this pool. Questions? It's based on a label that you apply to your node. Mm-hmm. Yeah, it's just it's another YAML, you know, and you just apply, yeah, it's a node identifier YAML. It's like when you remove the taint to have, like if you wanted to run workloads on your master, it's a similar process. So it's just a key value pair in associated with your node. So Kubernetes, and I'm going to get to this in another slide, but I'm going to talk about it now too because it's that important. Kubernetes is a declarative system. Everything in Kubernetes hangs off of what namespace it's in and what labels you've associated with it. So you have to declare, well, someone's going to fall. You have to declare, all right, this is my DMZ workload. This is my front end workload. This is my back end workload. You have to declare all of that with labels. And it's no fun to set up that taxonomy, but you got to do it. Don't be like some of my customers. I come in there and I'm like, oh, you're running everything in default. Isn't that cute? And I'm in sales, so I have to be nice. I can't go, are you an idiot? But, you know, I'm thinking it. But there's lots of places that wind up like that. And then they're like, we don't even really know what's running and we don't have any way of knowing. And I'm like, yeah, because you missed the whole declarative part of Kubernetes. It's not just fun with containers. You got to declare. All right, I'll get off my soapbox. But yes, labels are very important. You label everything in Kubernetes, even your nodes. Yes, this is the topology level. This is the namespace and workload level. So if you want to use an IP pool and a namespace and workload, first thing you're going to have to do is declare the IP pool with a YAML. Then in your namespace definition, you're going to add this annotation. And that's where you tell it pull from that particular IP pool. You would do the same thing in a particular workload YAML. So if I had, you know, an Nginx YAML, I would add that same annotation in there. Now, if you have an annotation at the namespace layer, that takes precedent over an annotation that you put at the workload layer. So if my namespace says this IP pool, and then I try to run a workload in that namespace that called a different IP pool, it always defaults up to the namespace rules. That's how Kubernetes works. Questions on IP pools? Am I going too fast? All right. Okay. So, oh, yes, question. That would probably be something you would want to shake out in your CI/CD system earlier in the process. Yeah. Yeah. But it won't, no, Kubernetes won't fail that out by default. But you would want to have that kind of testing happen earlier in your process. But yeah, Kubernetes will be like, oh, well, they said it here in the namespace, so that's what I'm going by, and I'm spinning it up. So yeah, but hopefully you've tested this, you know, CI/CD and Jenkins comes and goes, excuse me, sir. All right. More questions? All right, we're going to move on to the second aspect of Calico now. So we've covered the CNI. You're all CNI experts now. So now we're going to move on to the declarative policy aspect of Calico. And notice that's that word declarative again. That's a very important word, declarative. I declare. All right. So Kubernetes is kind of utopian in the way it's designed. Kubernetes is like, microservices need to talk to other microservices, man. They can talk to anybody. And that's true. By default, in Kubernetes, everything can talk to everything. So if you've got 5 workloads, that means there's 25 possible connections. I can do squares. If you have 10 workloads, that means you have 100 possible connections between them. Now, they probably don't need all of those connections. You know, your database probably doesn't need to talk to your web front end directly. Your middle layer probably doesn't need to talk to your web front end, but it can receive, or, you know, maybe your firewall doesn't necessarily need to be able to talk to your database, et cetera, et cetera. So all of these multiple connections are very useful when you're building microservices, but guess who else they're useful to? An attacker, of course. So if somebody does manage to compromise one of your pods, hey, guess what? Now they can get anywhere. And if you're used to a traditional security zone, you know, I've got my DMZ, I've got my middle layer, I've got my crown jewels down here and my, you know, highly secured layer or whatever. If something happens in one of those layers, the whole point of those layers is that there's the way where they can get from there is greatly limited. You know, if somebody manages to sneak into your web front end, they're not going to get beyond your DMZ. They're going to be stuck there in the DMZ. But if this is your web front end and you're in Kubernetes, hey, guess what? They can get everywhere. What's that? BusyBox. Yes, BusyBox. All right. So what we recommend at Calico, Tigera, is identify the communications that your workloads actually need. All right, microservice A needs to talk to microservice B, but it has no business talking to microservice C, D, and E. Then you set up a rule that says microservice A is allowed to talk to microservice B, and that is it. And same thing, you know, database X is allowed to talk to microservice Y, but not the other way around, and not to microservice Z and everything else. You set up those specific rules. So you identify the connections that are actually necessary and limit them. Now, traditionally, you would do this with a firewall, right? this is kind of, firewall work. This is what you would do traditionally. But remember when I was telling you that not all the packets even leave the node? If your firewall is sitting out on the network, it's not going to be able to firewall that stuff that's, maybe never leaves a node. Now, what people have done to solve that problem is it's called hairpinning. Have you ever seen this? So basically, they take all their east-west traffic and force it to leave the Kubernetes cluster, go through a firewall, and then come back in again. And good luck tracing that, because it's been natted, maybe natted again when it hits the egress, then natted at the firewall, and then natted again at the ingress, and then maybe natted again when it finally gets to your pod. So I don't even know how many. It's like too many nats to even think about. But that's what people do. I've worked with lots and lots of customers that hairpinned all of their traffic out of Kubernetes and back in for east-west traffic, because that's all they can do. Because they know, they're like, well, if we don't do that, there's going to be stuff going on in the kernel that our firewalls will never even see. All right. So we recommend a couple of things. We recommend namespace isolation. So namespace A can only talk to namespace A, it can't talk to namespace B. For example, if you have to be PCI compliant, you could set up a PCI namespace. You could set up rules that say only workloads that are in the PCI namespace can talk to other workloads inside the PCI namespace. If another workload tries to talk to these and it's not inside the PCI namespace, drop the packet. You can set up that kind of isolation. Or maybe you have multiple customers, customer A and customer B, and they might not like their data commingling in Kubernetes. You could have namespace per customer and set up the isolation for a multi-tenancy situation. But beyond just plain old namespace isolation, at Tigera, we recommend you take it a step further. You isolate the namespaces, but then you also limit the communication inside the namespace. So you drill down to microservice A can talk to microservice B in namespace C only. You get to that level of control. The ultimate goal is what we call zero trust networking. Who's familiar with zero trust networking? I realize it's a buzzword. And the thing to remember about zero trust networking is it's a goal. You're not going to magically have zero trust network tomorrow. If you set out to have a zero trust network, you'll probably have it by Christmas. That's how they work. You have to systematically identify every single thing that's talking that you want to talk and whitelist it. That's how a zero trust network works. It has to be only whitelisted communications happen on your zero trust network. And to get to that, you're going to have, that's a project. So you're not going to just flip a switch and magically have zero trust networking. And if somebody tries to sell you zero trust networking by flipping a switch, run, because they're selling you snake oil. All right. So yes, these are some of the examples I was talking about: stage separation, translation of traditional firewall rules, building the 3-tiered infrastructure, compliance, or any combination thereof. All right, now we're back to my declarative soapbox again. So you have to spend some time on your Kubernetes taxonomy. It wasn't Kubernetes, but back when I was at Splunk, we had to build the internal Splunk taxonomy, and it was the worst meeting ever. We called it the GOAT rodeo. And we'd always have it late in the afternoon on a Thursday or a Friday because everybody wanted to go drink afterwards. It was like a 2-hour, very painful meeting, but it was such an important meeting. We had it back in the early days of Splunk, and it made a huge difference in the later days of Splunk. We spent the time and the suffering to build the taxonomy, and then the taxonomy grew with us. And I highly recommend you all do the same thing for your Kubernetes. Spend the time, figure out your declarative policy, figure out your namespaces, figure out how you're going to label things. Are you going to use service accounts? What are those going to be? Those are all part of this process. It's painful. It's no fun, but it's very important. It's very necessary. And whether you use Calico or not, Tigera Secure or not, every other product in Kubernetes uses these same labels, uses namespaces and labels and declarative policy, because that's what Kubernetes is. It's a declarative engine. So whether you use Calico or not, you're going to have to deal with your taxonomy. All right. So you've labeled everything. You've got things in intelligent namespaces. So then you can start to build rules based on these labels, based on these namespaces. You do them with label selectors. So equality-based, equals or not equals, or set membership, environment in production or QA, tier not in front end or back end. So you can do these kind of complex matches to build your policies inside Kubernetes. So even if you don't have Calico, you just have plain Jane Kubernetes or EKS or AKS or some other flavor of Kubernetes, you can have Kubernetes policies. Project Calico, we put these policies in Kubernetes. This was our big security addition to the main Kubernetes project. So you can have Kubernetes policies whether you have Calico or not. So I'm going to show you Kubernetes policies here. These are available no matter what. Kubernetes policies have a couple of limitations, though. They're only inside a namespace. There are no global Kubernetes policies, and we'll talk about some global policies later. But you can absolutely set up and achieve easy namespace isolation with just Kubernetes policies. So they work off of a pod label selector or a namespace label selector. You can specify protocols and ports. Now, as soon as you build one network policy for your namespace, that namespace becomes isolated. It basically becomes a zero trust network. So you'll have to build a policy for everything else. Once you start doing these policies, you're going to have to go and spend the time to find all your communications for that particular namespace. So here's an example. We have 3 processes running in the same namespace. We have a front-end process and a database process. We want the front-end process to be able to initiate communication with the database process. We don't want the helper process to be able to talk to the database process. So here is our Kubernetes network policy YAML. Now, you can tell it's a Kubernetes network policy and not a Calico network policy because it says API version networking K8s. That's your big hint. You can also tell it's a network policy because it says kind network policy. And everything in Kubernetes has a label, including your network policies. So it has a name, my network policy, and it's associated with a namespace, my namespace. Then here we have our spec, our pod selector, match labels, role DB. So what does this mean? This means any workload in the my namespace that has a label role DB associated with it is going to be governed by this rule. Now in this example, there's just one workload that has that, but you could conceivably have multiple workloads that have that. All right, so that's how we're saying, who does this apply to? Applies to them. Then we say we're going to build an ingress rule. You could also build an egress rule. And then here we have another selector, pod selector, match labels, role front end. So that means any workload in the my namespace with the role of front end is going to be associated with this rule, and it's going to allow ingress from them on TCP on 6379. So as soon as you apply this policy, it's going to default deny anything else. So automatically the helper will now be default denied because it's not in the policy. So this is a Kubernetes network policy. If you're running Kubernetes at home right now, you can go home and apply these policies when you get home. You don't have to install Calico. Questions? Where does it say the action? Ingress. What's that? So there is only permit. There is no deny at Kubernetes Network Policy. If you want to get to deny, you got to have Calico. That's coming up in another slide. So Kubernetes only allows, but as soon as you have a Kubernetes Network Policy, everything else becomes a default deny. Question?
All the cloud providers, especially Google, they have a concept of tagging. So tagging is kind of, you have a plan to kind of support that. So right now on our computer, we have a 2.5 case management one. But if you set up cloud policy and everything, network, and that's kind of creates a confusion, right?
So Tigera Secure, our non-free product, will absolutely integrate network policies with Kubernetes policies. Currently, we only do it with AWS, but we're working on Azure and Google for that. But open source Calico, I don't know if that's on the roadmap or not. I don't think so. Yeah. More questions? But yeah, absolutely. That's something very common our customers have is they've got a security scheme for external services in Google or AWS, and then they want to try to make them match inside Kubernetes. Yeah, yeah. More questions? Yes. Yes. Yeah, you could have an egress rule as well. Yes. Absolutely. You could say, you know, the database is allowed to talk to the helper to, you know, maybe dump its log files or something like that. It could send something out. You could set up that kind of rule here as well. Yep. Anytime, as soon as you apply it, if you want to just completely isolate your namespace, you could just have basically a blank Kubernetes network policy, and that will just isolate your namespace. All right. Now we're moving into the Calico world. So that was open source. That was Kubernetes. You could run that no matter what. If you've installed Calico for network policies, you get the following superpowers. You get global network policies. Calico allows you to have policies that apply across your cluster, not just based on a namespace. This is handy if you say, for example, subscribe to, you know, known bad actor lists on the internet. You could programmatically set up default denies to any known bad actors on the internet across your cluster. You could also, for example, say, I never want any of my workloads going out to the public Google DNS servers. You could set up that kind of global policy with Calico. Because remember, it was the DNS that hacked it. Anyway, so besides, one of the other key capabilities of Calico is you can build your policies based on service accounts. Does everybody know what a service account is, Kubernetes? It's basically a user account for your workloads, basically, if you think about it. So why is that handy? Well, say you have a rule that you want applied no matter what. Like, I never want any of my data to accidentally go to North Korea, or I never want anything to ever look up DNS on public Google DNS servers. You have those kind of, you know, golden rules that your security, your SecOps team really is, that's very important to them. But a developer might have full control over a namespace, but they don't have full control over service accounts. So a developer could control his or her whole namespace. But if you're tying your policies to service accounts, they don't have control of those. Well, of course, they're a Kubernetes admin. But if a bad actor has root access, then ain't no software going to help you. All right. So besides the service accounts, you also get label expressions, traffic specifications. So you can do port ranges. You can do network sets. So that's how you would say block the Google DNS using network sets. The other thing is Calico runs on Linux. If you have standalone Linux, lots and lots of customers have like a MySQL database that's sitting just outside of Kubernetes. They're not running it in Kubernetes because they don't have Portworx yet. But, you know, so now it's sitting just outside of Kubernetes. And they can install and run Calico on those Linux nodes as well. And so basically you extend the umbrella of Calico to just outside your cluster. So Calico will run on standalone Linux nodes. Now, don't confuse that with Calico for Windows, because there is Calico for Windows, but it's only for Windows Kubernetes nodes. You didn't mishear me. Windows Kubernetes nodes. So you either have Tigera and Calico to thank or Tigera and Calico to blame for Windows Kubernetes nodes, because if you want a Windows Kubernetes node, you're going to be running Calico. That's the only networking solution for Windows Kubernetes nodes. Yes, there are. Yes, several large banks with large .NET infrastructures are running Kubernetes for Windows, yes. Yeah, it's C#.NET. It's all that. Yeah. So yeah, there are people that there is. I can't name their name. They don't want me to name their name, but there is one bank that is literally running Kubernetes for Windows in production right now. They have like 90 Linux Kubernetes worker nodes and 10 Windows Kubernetes worker nodes. They are part of the same cluster. As of Kubernetes, what is it, 115? That was when it came in? It was like in March of this year. But yes. They're on-prem. Yeah. But yeah, if you're going to be doing that, you're going to have to buy Calico, because that's the only thing that runs networking for Windows for Kubernetes. So, but that's not the same as what we're talking about here. What we're talking about here is just installing Calico on a standalone Linux server, which comes with open source Calico. Questions? I should do a whole talk on Kubernetes Windows nodes. Just because people are like, wait, what? that's my 9 times out of 10, that's the reaction when I start talking about it. They're like, you're joking, right? I'm like, no, I'm not. I'm not. So, all right. Let's talk about a Calico network policy now. So this is kind of an extreme case. This is an extreme case for a network policy. So here's the kind of use case here. You have a workload that starts behaving strangely. It starts doing things that lead you to believe that this workload might be compromised. So you take care of it, you spin up another copy of it maybe, or you on a different server, or you have some kind of failover, something else takes over for this workload. Now, normally you might be tempted to just kill the compromised workload. All right, it's compromised, let's kill it. Well, here's why that's bad. As soon as you kill that workload, the way containers works, all the evidence that was inside there goes away. It's poof, it's gone. There might be some log files left, but nothing, like you will not be able to know anything that went on inside there. It's not like just turning a VM off. You can't just go turn it back on a couple days later and start to, do your triage. No, you kill a container, it's gone forever. So what we recommend you do is you go and you edit that container's definition and you add a label to it. You add a label that says quarantine equals true. Then as soon as you do that, this policy is going to take effect on that particular workload. And now this workload is a global network policy. So any workload anywhere in your cluster that gets quarantine equals true added to it will fall under this quarantine policy. Here's how it works. So here we've got, you can tell this is a Calico policy. It's got a name, but Calico policies introduce something called the order field here. And the reason why is because Calico policies allow you to have a deny. Now, if you've ever worked with a firewall, if you have a deny high up, that's going to break everything. So you're going to want that deny to probably be down at the bottom after all your other rules. The only way you can do that is if you have an order. So Calico introduces order to your policies, to your rules. So the lower, the more precedence it has. So a policy with an order of 1 would have precedence over a policy with an order of 5 or 500. So, all right, here's our policy. It's got an order of 200. It's medium. It just depends on how you've numbered your policies. Now, here's where it gets interesting. So, any workload, quarantine equals true. It's a global network policy, so all your namespaces, no matter where they are. For ingress, it's going to log. So anything tries to talk to your quarantine pod, it's going to log that communication to the kernel log on the node, and then it's going to deny it. Same thing for any egress. So if your quarantine workload's trying to phone home to its command and control, any egress attempt is going to be logged and then denied. Now you'll notice we have log then deny. If I switch the order, that wouldn't work. As soon as the deny hits, the packet is gone. So we have to have log, then deny. And so now you can start to do CSI Kubernetes. You can start to figure out who hacked my pod, what were they trying to do with it, who was trying to talk to them, who were they trying to talk to. You can start to get that kind of information. Leave the pod safely running, but still get that kind of CSI Kubernetes information. Question? Yeah, it would apply to all pods in your replica set. Absolutely. Yeah. Now, kind of, I jumped over a bunch of other stuff that you would have to do in the back end to do this. Like you'd have to spin up a copy of this compromised workload to, so your website doesn't go down, or, if you're an airline, so your planes don't fall out of the sky. But there's other remediation that you would have to do. But yes, it would apply. If you had one copy of this pod or 10,000 copies of this pod, it would apply to all of them. Now, you could conceivably scale it down to 1 or 2 just to, since you really just want to know what's going on. You don't need all the other copies anymore. But yeah, it would be however many are in your replica set. That was actually compromised. Yes, you don't know yet. You don't know yet until you start looking at the log files. Yeah, absolutely. Probably not. Yeah. There could be, yeah. Now, Aquasec isn't going to notice a compromise necessarily. Aquasec will know if you've got, maybe someone CVE or other, Aquasec will notice that. It'll eventually get around to your 0 day, but Aquasec doesn't do the network security. So that's what you would use Calico for. It could, yes. Yeah, it could. Yeah, depending on what you're doing with your logs and how you're looking at your logs and your network security. Yes. We're storing it in the kernel log, but only because we explicitly told Calico to log. Calico doesn't log by default. You have to tell Calico to log. If you want detailed flow logs, you're going to have to come see me in the alley for Tigera Secure, which costs money. We have detailed flow logs, but Calico has logs, but only when you explicitly tell it to. Tigera Secure flow logs everything. Uh-huh. Uh-huh. Yep. Yeah. Yeah. Well, Calico doesn't use Fluentd, but Tigera Secure uses Fluentd for its logs. Yeah. Calico just writes to varlog Calico on the node. Doesn't use Fluentd. You can use Fluentd to pull the logs out of Calico, but by default, Calico doesn't ship with Fluentd. Our paid product, Tigera Secure, ships with Fluentd, specifically to send to Elastic or to Splunk or to whatever. Yeah. What's that? Yeah, so the information would be in that, oh, you mean in the log? It depends on, you can configure it, you know, so it's, you know, what log mode you want it, you would put Calico in that circumstance. So I think the default is debug, so you'd just get like basic, but if you turn that up, or I think the default is warn, and if you turn it up to debug, you get more. Yeah, it's typical logging settings. Questions, more questions. These are good. Multi-cloud, as in, oh yeah, you can run Calico for policies. You can run Calico for policies almost anywhere. The only place you can't run Calico for policies that I know of is Pivotal. Everywhere else, AKS, GKE, EKS, IBM Cloud. I even did Calico on Oracle Cloud. CNI is different than policy. Remember, there's two parts to Calico. There's the CNI part and there's the policy part. The policy part you can run almost anywhere. The CNI part, if you remember that slide with you know, Mesosphere and Anthos, that's where you can run CNI. Oh, you can run the Calico CNI on AWS if you're running upstream Kubernetes or Docker or Rancher or DQIQ. Does anybody do that? Nobody does that. That kind of multi-cloud, like you're going to have a single Kubernetes cluster across. Yeah, nobody does that now. I mean, Mesosphere talks about them doing that, but even they don't do that. Like, yeah, nobody, literally no one does that now. And if you came to me with that, I would tell you, you're going to have 10 times the headache. Just run 2 different Kubernetes clusters. Yeah, the kind of headache that would cause is insane. But you know, when somebody finally solves it, maybe Calico will do that. I don't. Yeah. So, question. It logs the package and then denies them. Right. So adding the selector quarantine equals true is what activates these ingress and egress rules. Yeah. So you would add selector, you wouldn't call it selector, you would just call it label on your workload. So you would do kubectl edit my compromised workload, and then you would add, like, probably don't call it that, but then you would add label quarantine equals true to that particular workload, and then that's when this policy would kick in. Now you could, I want to update these slides. I want to have a more generic Calico policy that's not so extreme as this one. This one's kind of extreme. But you could have a much more mundane Calico policy that says, I never want anything to ever talk to 8.8.8.8. You could have that kind of policy, or 8.8.4.4. And if you don't know what those two are, you don't work in security. More questions?
Segment and then network policy for rules for applications that span segments. See that happening with customers.
Absolutely. Oh yeah. Yeah, absolutely it happened. Oh yeah. It's not a common scenario yet. And it depends on how groovy their security team is. And by groovy, I mean Kubernetes knowledge. Like a very large bank absolutely does that, but their security team was on board from day one. Their security team absolutely didn't want to do that hairpin thing. They wanted to recreate that kind of situation, but inside Kubernetes, like extend the zone inside Kubernetes. But, you know, if somebody says, no, I need physical, I need air gapped between my zones, then you're going to have multiple clusters in that circumstance. And we have a large customer in Europe that they need to keep their network streams separated, but they're doing it this way because they're saving I was about to use a dirty word. They're saving a poop ton of money on firewalls by using Calico instead. So they're saving a ton of money because as you move to Kubernetes, one of the things we didn't talk about here about, when you move to Kubernetes, you take your monoliths and you start breaking them into microservices. Well, those monoliths were talking to themselves. They were writing to memory. One part of the monolith was writing to memory. Another part of the monolith was reading from memory, or maybe it wrote to disk and something else read from the disk. Like, it had ways of talking to itself that didn't involve the network. As soon as you start moving to microservices, 12-factor apps, and all that groovy stuff, guess what? All of that stuff that used to happen inside the monolith is now going over your network. So your east-west traffic is just going to balloon. So to be able to hairpin your east-west traffic, you can't buy the baseline firewall. You have to buy a really good firewall to be able to handle that and be performant. So it gets very pricey. Yes. Yes. And meet me in the alley and I'll tell you how we help you solve that with Tigera Secure and our amazing flow logs. Yeah. Because one of the problems that traditional flow logs have with Kubernetes, traditional flow logs have, source IP, destination IP, and a timestamp, maybe a protocol. That's about it. Well, here, that's great in a VM world or, where things keep IP addresses for 24 hours a week or a month. But in Kubernetes, a single IP address can bounce to 10 different workloads within a 24-hour period. So you could have 10 completely different services all using the same IP address. So if your flow logs just have that IP address in it, it's like, all right, well, something talked to something at 3:30, but I have no idea what talked to what. So that's why we have our magical flow logs that include the source namespace, destination namespace, and all that good stuff. So, yes. Uh-huh. Yes, yes, Calico. Oh, that's something I should add to this talk. Actually, is Calico has policies for your workloads and your pods. You can also have Calico policies for nodes. So you can have how the nodes communicate controlled by Calico as well. Yes. Now, you can't run the Calico CNI in AKS, but you can run Calico for policies in AKS. Oh, cool. Okay. Yeah. Yeah. You can run that. But yeah, you're stuck with their CNI. It'll get better. Like Amazon's CNI just improved a oochie teeny weeny little bit. So, you know, there. But to me, that's an argument for running Rancher, Docker, D2IQ, something like that, upstream or pure upstream Kubernetes. But you can use the Calico CNI with Rancher, and you can bin pack, and you can do all that cool stuff I talked about at the top of the hour. And you have access to your master nodes. I mean, you can audit your master nodes. You can, yeah. So. But yeah, if you Kubernetes ain't for lazy people, I'll tell you that right. Okay, but what about security? What about, you know? All right. Google does. And what do they use? They don't use Cilium. They do not use Cilium, though. They use Calico. The other thing is with Cilium is it is a resource hog. You know, you'll see all the other CNIs on the chart will have this little teeny tiny thing, and then Cilium's like on the resource usage. So now the whole BGP versus what's the other one? eBPF. Calico includes eBPF now. Oh yeah, it's included eBPF for about 6 months now. So you can absolutely use eBPF. But I will tell you this, eBPF is part of Calico, but eBPF has been oversold. eBPF is good for certain use cases and not others. So you have to, it's not a panacea. So, yep. Absolutely. But yeah, so as far as Cilium is concerned, it's if you turn off encryption, it competes. If you turn on encryption, your AKS bill is gonna go through the roof. Oh, the CNI, it would don't, yeah, GKE on-prem uses Calico. GKE and Google Cloud doesn't use Calico CNI. Yeah. What's that? I don't think so. And you absolutely can in AKS and EKS. Yeah, they use their own CNIs. Yeah. But you, like I said, you can run Calico for policy almost anywhere. If I was going to run upstream Kubernetes and Amazon, I would use kubeadm to stand it up. Yeah, but I come from Heptio, and Heptio was kubeadm, live or die. The Heptio was so that's where I got my kubeadm prejudice. So that's what I learned on. So, but you know, COPS, Kube Spray, whatever makes you happy. if as far as that's concerned, yeah. Well, I personally don't see that as a problem. I see that as a benefit. But yes, for somebody else, that could be a problem, managing your master nodes. Yes. Because you can audit them, you have full control over them. And when something goes wrong, you're in there. You're not just calling some AKS or EKS engineer to try to help you figure it out what's going wrong. You have, I guess I'm just a control freak. Yes, you can, yes.
Yeah, so one downside of it is, I mean, I recently, my SecOps team, we were running AKS on Azure, and we were controlling the master nodes, working nodes, and then we run through bench and bundle. That list was, we got a very big list from SecOps, and to mitigate all those problems, that's going to take at least a month for us to sort down each and every vulnerability that is open on your.
But how do you know there aren't those same vulnerabilities when Microsoft is managing your control plane? You don't know because you can't run that on them. It's a black box. Okay. You know, most of my customers are on AKS and EKS here in the middle of the country. So I'm in the middle of the country. I am in AKS, EKS land. Most of our customers on the coasts are either upstream Kubernetes, some are OpenShift. But yeah, here in the middle of the country, it is definitely AKS, EKS land. Yeah. Well, and part of that too is because everybody wants support. And Heptio's gone. So there's no real independent Kubernetes support. If you're running upstream Kubernetes, who are you going to turn to? So that's why I think that's forcing a lot of big companies to places like EKS and AKS as well, because that's supported. Sure. All right, one last slide, folks. Sorry, we digress. So there is, Calico has a CTL. Every version of Calico that comes out, we try to make it so you need the Calico CTL even less. It's funny because I'll call it Calico Cuddle because I could envision myself cuddling a cat, but I don't call it Cube Cuddle. It's Cube CTL, 100%, because who wants to hug a cube? But anyway, so Calico CTL uses the same backend as Cube CTL. And generally speaking, we've tried to eliminate the times you have to resort to Calico CTL. So most of the time, like for those Calico policies that I was showing you, you apply those with Cube CTL. So, or you stick them straight in the Kubernetes API. So we try to make them, we're trying to minimum every version of Calico that comes out. We have less and less reason to resort to Calico CTL. But if you might need it, it runs on Windows, it runs on Linux, it runs on Macs, just like kubectl. All right, and that is the end of my talk. Thank you all very much. More questions? Otherwise, there's pizza and beer. Generally speaking, in all of the bake-offs I've seen, Calico comes out on top as far as the CPU and memory. But if you look at Calico, Flannel, and some of the other typical ones, they're all within like a couple of hundredths of a % of each other. It's only when you get to Cilium, like I said, do you see that Cilium is like 100 times more overhead than all of the other ones. So, Calico, Flannel, Weave, they're all up there with this little tiny overhead. It's, Calico has been part of the Kubernetes core since Kubernetes came out. So, like I said, Calico was handing out IPs to containers before Kubernetes was even released publicly. More questions? All right, thanks a lot, everybody.
So next month we'll be here again, guys. September 18th, we're going to have Cockroach Labs talking about running Cockroach DB on Kubernetes, and I think Tigera's coming back. I don't know if it'll be our buddy Drew, but somebody will be. All right, thanks for coming, guys.